CC, please. Thank you.
Hello everyone, thank you for coming to my session. So yeah, today I'm going to talk about how to make your own domain-specific language, and this is my actual name, which is Chaw Chit Su Thwe, but everyone call me CC, and yeah, I'm originally from Myanmar. So yeah, I'm now working in HK, which is a Tokyo-based cloud security company, and we provide solutions like single sign-on or like data loss prevention solutions. So yeah, let me start with a really simple quiz. I will ask you, I will give you some example, and please raise your hand if you think this is like general purpose or domain-specific language. So in Hangul, we have this term called access condition expressions. Basically, with this expression, we determine if the user is allowed to log into our system or not. For example, we could define like IP addresses, or it can be login name, or it can simply be operators, and then you can connect these like expressions. So the question is, do you think this is a domain-specific language? Please raise your hand. Exactly. So basically this works in our system. It won't work outside if you haven't developed it yet. And another example is that emoji code that I found through our internet. So this is what the print statement looks like in emoji language. And this is where they define dictionary, and they look through the dictionary and then print the item. So please raise your hand if you think this is a domain-specific language. Yes, so basically you could actually use it as like a Python, general purpose programming language. So another example is HTML. We all know what HTML syntax looks like. The question is, raise your hand if you think this is a domain-specific language. This is actually considered as a domain-specific language, since this is the domain is the web browsers. So now we know what's the general purpose programming language and domain-specific language. I would like to give you some background. Last year I joined PyCon HK, and the keynote speaker talks about how programming language are very mixed in English. And if as a person who is English is a second language, basically if to learn programming language, you have to start with English and then I go to programming language. And I resonate with it so much because I used to work in the education field where we taught children programming languages. And so when we teach children a language, we start stories are important. So this, with everything combined, this what today talks about. We're going to talk about how we can make a storytelling programming language for kids. So that's the domain. You have to understand, the step one, you have to understand what your domain is, what you're trying to do. And again, we're going to make a storytelling code, and the kids are the audience. The step two is actually choosing what type of domain-specific language we are trying to make. There are two types of DSL, internal or external. Internal basically follows the host programming language syntax, like a library that you import in your Python code. For example, PyTest. It still follow your Python's syntax, but there are specific rules that you have to follow. Let's say you have to add like test as like a word in front of your function when you define the functions. Now, so for the external DSL is that it has its own syntax. It's totally different from your host programming language. For example, SQL. If you know how the query language works, you could basically be an expert in this field without knowing your programming language. So today we are going to create our own syntax and try to make an external DSL. Now we know we have to make our own syntaxes. Step 3 is actually designing a syntax, where I spend a lot of my time trying to come up with syntaxes. So first, when we teach, when we learn languages, we're trying to make a sentence. So that's what I'm trying to go with. I'm going to make a sentence. That's what my syntax looks like. They are basically a sentence. But it's in Japanese, I'm sorry. Basically what's saying is that cat is saying hello. And then this is another example syntax, declaring before I use my cat subject, I want to declare that this is a character. So what it's saying is that cat is a character. Now, these are the XML syntax that I created, and step 4 is actually building a parser. So parser is basically made of 2 components. The first one, you have to so we have to know what's lexer. Lexer basically breaks down your syntax into like tokens. For example, we have cat is saying hello, so we're gonna break it down into each token types. So cat is a character, and we have particles, and we have a string, and we have ita, basically is a say token. So with these tokens, we are going to make a parser that's actually extract relevant information. Particles are basically useless in my system, so we're going to drop those particles and like other unnecessary information, and what we left with is that we're going to say something, and the subject is the cat and hello is the string that we're going to print. So we know it can be in different structure. You could define tuple or class or dictionary. We're not gonna make a parser from scratch. We're going to use some libraries. The first one that I came across is lark. This is the XML syntax that we're gonna explore. So we have hello, comma, word, and exclamation mark. What lark? So after you pass that string into lark, it gives you a tree subject, a tree class, and then it gives you like tokens. Another library is ply. You have to like define a grammar syntax, like word, comma, word, exclamation mark, and then you extract words that is important, relevant information to you. And you can structure it into different way. Now here, as using tuple, it can be other structure as well. So in the end, I ended up using ply mainly because it gives me more flexibility on how my data structure is supposed to look like. And we're gonna explore using the ply. So for the print statement, this is my print statement. We have to define tokens. We have subject, we have got particle, we have string, and we have say token, we have period. And then we have to define our regis, token regis. So subject, I'm going to accept like emojis, and we have got particle, and I accept like this is past tense and this is present tense with or, so it accept both. And then we have a function where it's gonna strip the bracket and it's gonna return just string. So here you have to you can either use just regis, or you could use a function where you could do more operations. And then we're gonna define our grammar. And we have subject, we have particle, string, and token is say, and period. And we're gonna extract what's relevant to us. This is say is a keyword that will be important later. And then we're gonna extract subject and string. Another example is the declare. This is another declare statement. The same way we're gonna define the grammar, and then but we have our new custom attributes here. What we did is that we're gonna put subject into defined characters, where we're gonna check that if the subject is already defined or not in our print statement, and if it's not defined, we're gonna return error. If it's already defined, then we be able to use. So another example is if else. This is the if else statements that I came up with. Basically, if greeting is the identifier, is hello, then cat's gonna say hello. If not, cat's gonna say bye. Again, this is the grammar structure of my if statement. What's important here is that I want to make my if statements to understand that there can be multiple statements under if condition. So I have to define like another parse function. so that it understands multiple statements. What's essentially doing here is that, let's say it see two statements. It's gonna go to first statement and it's gonna parse it, and the information gonna be saved in the list, and then it's gonna go to next one, parse the sentence, and then it will put it in the list. And I want to talk about compiler and interpreter. So compiler, basically you have your domain-specific language, you parse it, and that information gonna be generated into machine code or other language like Python, and then you're gonna run that code, execute the code. So interpreter here, it remove the generating code steps, and basically you just gonna use that person information to however you want to execute. So we're gonna do interpreter approach here. So we're gonna have to write interpreter here. So for the print, let's say we already have our person information. So this is the keyword. We're gonna check the first item in the tuple, and if it's say, then we can use that information, the items, like subject and string, and we're gonna like print them like this way. Another example is this is my if structure person information looks like. We have if keyword, and we have our identifier value, and this is the value that we want to compare with, and this is true statements, these are the false statements. So because my system already know what to expect in the tree structure, if they compare the identifier value and then the string value, if it's true, they're gonna do the true statement. If not, it'll be false statements. So steps is actually executing. It's just like I grab all my codes and then pass it with the parser, and then from that person information, I'm gonna interpret them. Now that we have created every component that need to run make a domain-specific language, we're gonna see some action here. So this is me defining that cat is a character, and then I'm going to print that hello world. So this is basically how my terminus looks like. And another one, if I did not define that cat is a character, it's gonna say, oh, this is identified character. So this is other syntax that I have. We define it, print it, and then this is the identifier, which is a variable greeting, and then we assign hello into greeting. And from there, we compare greeting with the value, and if it's we print hello or bye. So here, because greeting is hello, it's print hello in the end. So what if we define something that's not that my system didn't recognize? That it will say, oh, this is syntax error. So as a recap, basically to make a domain-specific language, you first understand what you're trying to make. What's the domain? Trying to make it smaller, so that you can start really small, and then decide if you want to do internal or external DSL, and you actually come up with syntaxes, build a parser, and then decide if you want to do compiler approach or interpreter approach. So yeah, with this basic step, you can start making your own domain-specific language. So yeah, thank you. This is the end of my talk, and we are now searching for talent, and we can be part of it. You can scan the QR code is for the recruiting purpose, and you can explore our positions.